Okay, so let's solve this. Question number 5. So it's a very simple problem compared to the earlier problems what we have done. So here it's a simple arrangement. We have a pulley, okay, and two objects connected using a cable are hanging. Two objects, object A and B. A simple arrangement. The given data is mass of the object MA is given as 10 kg, MB is given as 6 kg, and you are asked to calculate the tension in the cable and the acceleration. These are the unknowns. So it's a very simple arrangement. Here there are no friction involved because no surfaces are in contact, and we can see here the mass B is lesser than mass A, so of course this system is going to move in a direction like this and this. Because of the weight of A will be moving down, B will be moving up. Just as we explained earlier, the amount of movement for downward movement for A will be equal to the amount of upward movement for B, which means that the acceleration for A and acceleration for B will be having same magnitude but in the opposite direction. Downward acceleration A for A and upward acceleration A for B. Now let's solve it. Compared to the previous problem, this is a very simple problem. We can directly jump into the free body diagrams. So I'm starting with A. So the free body diagram of A will look something like this. I have the mass. The mass of A is, the weight of A is 10 g, and there is a cable which will be having tension, and we know that as is a frictionless pulley, tension on both sides of the cables will be same, and as it is tension, we are drawing it away from the object. If it was compression, we would have drawn it towards the object, just as in the last problem. And the only other thing what we are having is the movement, the motion. Okay, for block A it is moving down, so acceleration is downward and it is A. Similarly, we can also try the free body diagram of B. So this is block B. The mass of the block B is 6 kg, hence it is 6g acting downwards. There is a tension which will be equal to as in the previous block case, and here the acceleration, this block is moving up with the same magnitude A. So these are the two free body diagrams, and directly we can define some coordinate system. Say I'm defining a coordinate system, say this is my x and this is my y, this is positive x, positive y. So I'm writing sigma fx equal to m times ax. Okay, and we have already calculated the value of ax. Ax is A. Is it plus A or minus A? That's what we want to consider. So x, what I assumed is upward. For block A, acceleration is downward, so it is minus A. Okay, now let's substitute. So sigma fx, t upward, same direction, minus 10 into 9.81. That is only two forces in the system, and on the right hand side I have the mass which is 10 kg into minus A. Okay, that's my first equation, that is t minus 98.1 is equal to minus 10A. I have my equation 1. Because there are two unknowns, I need another equation that I will be getting from block B. So here also I am trying the same, using the same coordinate system. Sigma fx equal to max. Here also I am considering the ax component. So considered x is upward, direction of acceleration is also upward, and the magnitude is A, so it is plus A. Now T minus 6 into 9.81 is equal to, mass is 6 kg, so 6 times A. So this is my equation number 2. Now on solving these two simultaneous equations, there are two unknowns, T and A, two equations, so I can solve them and I will be getting the value of A as 2.45 meter per second square and the value of T as 73.57 Newton. So these are the expected results for problem number 5.